Hi, this is Mrs. Doris. This is Lesson 2-8 entitled Proportions and Similar Figures. Our objective for this lesson is that you will be able to find missing lengths in similar figures and also to use similar figures when measuring indirectly. This is important because proportional reasoning can be used to solve many real-life problems. We start off with some vocabulary. Please pause the video as you need to in order to get your definitions. Similar figures are figures that have the same shape but not necessarily the same size. Scale drawing is a drawing that is similar to an actual object or place. An example of a scale drawing would be floor plans or maps. Scale. In a drawing, scale is the ratio of any length on the drawing to the actual length. And scale model is a three-dimensional model that is similar to a three-dimensional object. The symbol, and here you see it one squiggly line, means is similar to. In similar figures, the measures of corresponding angles are equal, and the measures of corresponding side lengths are in proportion. The order of the letters when you name similar figures is important because it tells which parts of the figures are corresponding parts. I'm going to demonstrate that in this first problem before we do problem 1. All right, finding the length of a side. In the diagram, triangle ABC is similar to triangle DEF. What is AC? And of course, the longer question is, what is the length of AC? Before we do that, let's look at our similarity statement right here and compare what we know about these two figures. First of all, what we know is that angle A is congruent or has the same measure as angle D. This is because angle A is listed first in triangle ABC and angle D is listed first in triangle DEF. All right, we also know that angle B, which is listed second, has the same measure as angle E because they are each listed second. Also, the last one, angle C, has the same measure as angle F. All right? Now, that said, we can also compare the line segments as well. So, for instance, we know that line segment AB, since those two letters are listed first, are proportional to DE. All right? We also know that line segment BC is proportional to EF, since those two are listed last. And it's also true that AC, the first and the last letters, and DF are proportional. All right, so we're going to use that last statement to solve this problem. Okay, first of all, we know that AB is similar to DE. So let's set up the ratio of the lengths, which would be 16 to 12. All right, we're going to just call AC X for our variable. And so we also know that AC is proportional to DF. So that's X over 18. Now that we have our proportion, we're ready to cross multiply. 12 times X is 12X. On the other side, we have that equal to 16 times 18. I'll move up here. 12X, 16 times 18 is 288. Divide both sides by 12, and we get X is equal to 24. All right, so X right here is a length of 24. Problem 2, applying similarity. A man who is 6 feet tall is standing next to a flagpole. The shadow of the man is 3 5/10 feet, and the shadow of the flagpole is 17 5/10 feet. What is the height of the flagpole? All right, well, let's draw a picture here, and you'll have to forgive me. I am not an artist. So we have a man who is 6 feet tall, and he has a shadow that is 3 5/10 feet long. All right, we also have a flagpole, and its shadow is 17.5 feet long. What we don't know and what we want to find out is the length of the flagpole. So I'm going to use the variable f to represent the height of the flagpole. All right, so let's set up our similarities here. And there's a couple ways that we could do it. The way I think I'll set it up is we're going to set up the height of the man, 6, as compared to his shadow, which is 3 5/10 feet. And that ratio will be the same as the height of the flagpole compared to its shadow, 17.5. All right, let's cross multiply. 3.5 times f is 3.5f. On the other side, we have 6 times 17.5. All right, let's go ahead and simplify that. 6 times 17.5 is 105. And then divide both sides by 3.5, and you get f is equal to 30. And be sure and label your answer in this case because we're dealing with feet. Our answer will be in feet. So the height of the flagpole is 30 feet tall. All right, problem 3, interpreting scale drawings. On a map, the distance from Jacksonville, Florida to Gainesville, Florida is about 6/10 of an inch. If the scale of the map is 1 inch is the same as 110 miles, what is the actual distance between the two cities? All right, well, let's set up our scale first. I have 1 inch is to 110 miles. And so when I set up the other side of my proportion, I want to put my inches on top, my miles on the bottom. So we are told that on the map it's a distance of 6/10 of an inch. Okay? And we want to know the actual distance, and we'll use m for miles. All right, so let's cross multiply. 1 times m is 1m. That will be equal to 110 times 6/10. And multiplying that out, we get 66, and that will be miles. So, to answer the question, the actual distance between Jacksonville, Florida and Gainesville, Florida is 66 miles. All right, part 2 of this problem. If you know that the actual distance between two cities is 250 miles and that the cities are 2 inches apart on a map, how can you find the scale of the map? All right, well, this is not a difficult problem at all. We know there's 250 miles in 2 inches. So this is basically like finding the unit rate. Dividing 250 by 2, we get 125. That would be miles per 1 inch. So that is the same as 1 inch. All right, and there is our scale. Usually they'll turn it around and say 1 inch is the same as 125 miles. All right, problem 4. The scale model of a building is 6 inches tall. The scale of the model is 1 inch is the same as 50 feet. How tall is the actual building? All right, so let's set up our scale, 1 inch to 50 feet. And so again, we want to put our inches on top, and the actual height of the building, I'll use B for building, is going to go on the bottom because it will be in feet. Let's cross multiply. 1 inch times B is B, and on the other side we have 50 times 6, which is 300 feet tall. All right, so the actual building is 300 feet tall. And I'm sorry, that's inches. Let's change that. Actually, I prefer, let's just write it out. 300 feet tall. All right, at this point, if you feel comfortable, you can work on page 134 and 135, 7 through 25, the odd-numbered problems. Please be sure that you show your proportion and show the steps of solving your proportion as you do the homework. If you need some more examples, then stay tuned. All right, we're going to do the lesson check on page 133. Number 1, you use a photocopier to enlarge a drawing of a right triangle with a base of 13 and a height of 7. The enlarged triangle has a height of 17.5 centimeters. What is the base of the enlarged triangle? And part B, what is the scale of the enlargement? Okay, well, here we go. We have a base of 13. So I'm going to put the base on top. Doesn't matter. And the height, that may seem backwards, on the bottom. But it doesn't really matter. So our base is 13 centimeters over the height of 7 centimeters. On our enlarged triangle, we have a height of 17.5. So since height is on the bottom, we're going to have to put our 17.5 on the bottom. And we want to know the length B of the base. All right, so here is our proportion, and let's cross multiply. 7 times B is 7B. On the other side, we have 13 times 17.5. Okay, I'm going to move up here. Multiplying together, 13 times 17.5 we get 227.5. Dividing both sides by 7, the base would have a length of 32 5/10, and since all of our numbers are in centimeters, so will the base be 32.5 centimeters. Now, the question is, what is the scale of the enlargement? All right. We can take either the bases of 13 and 32.5, or the heights of 17 and 17.5, and it really doesn't matter. I'll use the bases. And our enlargement is 32.5. And our original had a base of 13. And all we do is divide. So 32.5 divided by 13 is equal to 2.5. So our scale of the enlargement, it's 2.5 times larger than the original. Number 2, the scale of a map is 1 centimeter is the same as 75 kilometers. What is the actual distance between two towns that are 3 centimeters apart on the map? All right, let's set up our scale as one proportion, or one ratio, 1 centimeter to 75 kilometers. On the other side, since we have centimeters in the numerator, we're going to put our 3 centimeters in the numerator. And we want to know how far apart they are. I'm going to use K since we're dealing with kilometers. And let's cross multiply. 1 times k is k. On the other side, we have 75 times 3, which gives us 225, and that would be kilometers. 225 kilometers between the two cities. Number 13. Suppose triangle MNN is similar to triangle RST. How can you identify corresponding parts? All right, well, let's start at the beginning. M and R are first, so we would say the measure of angle M is equal to the measure of angle R. Next is the N and the S, so the measure of angle N is equal to the measure of angle S. And last, measure of angle P is equal to the measure of angle T. All right, corresponding line segments will be as follows. MN will be similar to RS, since those are first. NP, the last two letters, will be similar to ST. And MP, first and last, will be similar to R and T. And when I say they're similar, another way of saying that is they are proportional. Okay, number 4. Suppose triangle ABC is similar to triangle TUV. Determine whether each pair of measures is equal. The measures of angle A and angle T. Since A is listed first and T is listed first, our answer is yes. These two angles will have equal measures. Part B, the perimeters of the two triangles. Well, remember that similarity tells us that the angles are equal, corresponding angles have the same measure. However, the perimeters could be very different. One triangle could be much larger than the other. So our answer to the perimeters, or the distance around, would be no. And then part C, the ratios of the sides. And let's see, I forgot to check which sides they mentioned, but we'll just take AB and TU. And our answer to this would be yes. Those ratios will be the same because those are corresponding sides. Number 5, the scale of a map is 1 inch is to 100 miles. Is the actual distance between two towns 100 times the map distance between the two towns? Explain. All right, the answer to this question is no. And the reason is our units of measurement are not the same. 100 miles is much more than 100 times 1 inch. So for that reason, the answer would be no. If you have any questions, please ask or post online. Thank you very much.